right. Hello, everybody. Let me just get set up here. Today we are to our next chapter, starting our discussion on probability. Now, there are many ways to do a first probability discussion. I'm going to focus on certain things and leave out other things completely, which make things a little bit more complicated and that we don't need for our career goals, I'll say. There's always more to do, there's always more to say. Yes, those things are interesting, but we don't have that much time to spend on probability alone, unfortunately. So I'm taking a very specific approach to this. And if you know something about the topic, then yes, there are things I'm leaving out, but it's done on purpose. All right. So the first thing we should be aware of, I've mentioned it here and there briefly, but we didn't really write anything out and made it maybe very clear. It's just our language that we're going to use. When it comes to probability, which is the start of statistics, they wanted to use different words for things that we already have words for. So it's a little unfortunate, but it's the way it is. So when we talk about an element, when it an element is sort of produced from something practical, making arrangements on a shelf or rolling dice or whatever. They don't call it elements, they call it outcomes, which might be a more appropriate word, thinking of it from a practical point of view. It is a result of an experiment, result of some experiment, meaning some action that is performed to create some result. Then when we talk about sets, we view them as collections of these elements, which are now called outcomes. The new word for set is event. Maybe that wasn't a very clear N there. Let me make that clear. Event. But it's still a collection of some outcomes. Maybe all of them, maybe some of them, maybe none of them. Sets and events are interchangeable words for us. Then universal set. Universal set was the set that contains everything in question, depending on the topic that you're talking about. Here we're going to have the same concept containing everything, but we're going to call it the sample space. And usually we reserve the name S for sample space, just like we reserve the name U here. So why do they make new words for things that we already know? I don't know. I honestly cannot tell you. Just try and be different, I guess. Don't know. But these words are interchangeable for us. So as soon as I get to something more practical, an action that's creating results, we call them outcomes. We call collections of these outcomes events, and we call the collection of all possible outcomes the sample space. Nothing is really different. Nothing is new. It's just the words that we use. So feel free to use your existing words, your original. There's nothing wrong with that. But if you see these words in a question, you will have to know what they mean, of course. Okay, so that's the first thing, to just get out of the way. Let me just check if everything's working camera-wise. Good. Seems okay. Seems okay. Next, we now have to talk about the concept of probability. Now, this shouldn't be a new word, probability. But if someone asks you, what does that word mean? Perhaps you haven't really thought about it. So let's take an example. Let's suppose we roll 2 dice. They're different. Let's say a red and a blue die, whatever. And we're interested in uh, getting a double, two of the same number. Example, we could have 2 1s, 2 2s, and so on. We're interested in that. Maybe we're playing a game and you get an extra roll if you roll double or something, right? Those are special for sure. So then we can say, okay, out of all possible rolls of 2 dice, we're interested in some of them. Let E represent the event that a roll is a double. So this isn't going to happen all the time. But now we have an experiment. This is our experiment. The action that we perform, creating a result. Some of those results are desirable, some of them are not. Right. So when we talk about the probability, it technically has to be connected to some restriction, some event, some desirable result or collection of results. So the probability of event E occurring, we're going to write in short as P for probability and then E in brackets. Technically speaking, you need to define your event first, just like you do your sets, and then this should be completely sort of mathematical and symbolic using those names. But you'll see many books just write the words in the brackets, sort of relaxing that formality and just saying the probability, and in brackets, you roll a double. So we won't be too strict about it, but when I have the opportunity, I will try and be a little bit more precise and correct. So all it is, because each outcome is equally likely, these are two fair, balanced dice, that I'm just as likely to get 2 1s as I am to get 2 and a 3 or any result. Each outcome is equally likely. And that's the best case scenario, the simplest scenario, and the one that we want to focus on. If everything is equally likely, then this probability is as simple as, I'm going to write it symbolically first. No, not symbolically first. I'll write it in words first. Count the number of, let's say, of ways E can occur and make a fraction that out of the total number of outcomes. Let's say here, possible. So when I talk about a probability, I'm talking about a proportion, a fraction. The number of ways I can get what I'm looking for, rolling a double, versus all possible results. So in this case, my spacing's a little messed up here. In this case, I'm going to have two things, and that's going to make up my probability. The top will be the number of ways I can get a double. Well, it's the double 1, 2, 3, 4, 5, or 6. So there are only 6 of them. I can list them and count them. The total number of possible pairs of numbers that I can get, you can list them. You can think of, well, I have 6 ways for the first one, 6 ways for the second one, 36 possible pairs. Now, I don't care about simplifying this right now. In this case, because I chose something nice and simple, it simplifies. In other cases, it won't. Regardless, I get a fraction. A fraction. So I can write this probability in a short way as the number of outcomes in event E, just a fancier way of saying the number of elements in E. This was our way of representing the number in that set, right? Divided by all possible outcomes, meaning the universal set, the sample space, and in this setting we use an S. Now, whether you write it in words, whether you write it in a short way, what we're doing is exactly the same. We're trying to create this fraction. So the probability of any event, because it's always compared to the total, it's always going to be a fraction between 0 and 1. Always a fraction let's say ranging from 0 all the way to 1. I can't get less than 0. The worst case is if I have such a weird restriction that I cannot get it. There's 0 ways of doing it. It's empty. Then I'll have a 0 over a number, indicating that this is, let's say here, close to 0. The 0 indicates the impossible side. It's impossible that I'll get it. And the 1, well, if I have such a relaxed, loose restriction, I can actually get anything and I'll satisfy that restriction. Then it'll be the total over itself, giving me 1, saying that it's always going to happen. So I have this range and going in between. If I'm sitting fairly close to 0, then it's going to be quite unlikely. And when I'm sitting close to 1, it's going to indicate that what I'm looking for is quite likely. So the first interpretation of the probability as a fraction is to see where it sits between 0 and 1. And that indicates, depending on which side it's closest to, that indicates how likely something is. So the probability fraction fraction is a number, the probability value, it's a measure. I'm associating a number to tell me something. It's a measure of how likely it is to get, let's say, something that satisfies E's restriction if we were to do the experiment right now. If I'm going to roll 2 dice, I want to know before I do it, how likely is it that I'm going to get a double? Well, 6 out of 36, I can calculate that. Let's do it in the chat so we have something to look at. 6 divided by 36, It's not the hardest thing ever. Not the hardest thing ever. Random line. I get 0.1667 if I round to 4 decimal places. So this is fairly close to 0. Closer to 0 than it is to 1. Much closer, right? And I therefore conclude it's quite unlikely. If I'm going to do this experiment, if I'm rolling 2 dice, I don't expect to get a double. I could, there is a chance, but it's not very likely. So at the very first interpretation, the probability gives me a number to decide how likely something is. That if I compare this to something that has a probability of 0.2, well, that one's going to be more likely. So I now have a number, and it's easy to compare numbers. Whereas my feeling between the two, I might not be able to tell which one is more likely. We want to quantify it and put a number on it so we can examine it more closely and be able to decide when things are very close which one is more likely and which one is not. Okay, so there's a lot of benefits to putting a number, a measure, and associating that with a concept that can be quite unintuitive. So that's one interpretation. Another interpretation, let's say interpretation 2, this is 1, this is 2, is if you know from your prerequisite that I can make a fraction into a percentage. So in this case, this is the fraction, this is the probability, but I can also view it as a percentage. It would be 16.67%, right? I have a lot of arrows and all kinds of things going all over the place here. So if I look at it as a percentage, it gives me another interpretation for the probability as follows. If we did this experiment, rolling 2 dice, experiment, many times. You do it over and over and over. Every time you see, do I get a double or not? Do I get a double or not? Over and over and over, thousands and thousands of times. And with a computer, it's fairly easy to do, right? Many times. Then we will get a double, which is our event in this case, about 16.67% of the time. Now, if I didn't do it many times, a lot of things can happen. If I roll 2 dice just a couple of times, I can be extremely lucky and get a double both of those times and be at 100% success rate. But the more I do it, the closer it'll get to this probability percentage. And if I just do it enough, it'll start to stabilize and get closer and closer on average to this percentage. Okay, so both of these are correct. They're in a sense equivalent, but sometimes I want to see things as if I'm going to do it right now, what do I expect? Just from one. So the probability is a measure of what to expect from one run of the experiment. Or I can think of it as a long-term average, still indicating what's likely or how likely something is, but more of a long-term view that if I did it many, many, many times and I average the number of times I got what I'm looking for, it'll be that specific proportion, that specific percentage of my total repetitions. So it's important to understand what a probability is trying to say, either one of those, or both sometimes. That when I calculate a number, That number is there to tell me something. It's not there just as an academic exercise and then I move on. In this case, we're looking to get a number so that it can specifically give me information about something that I might not have a good feeling about. In more complicated situations where I don't roll dice, it's sometimes very unintuitive how likely something is. What I think is very likely turns out to not be likely at all, and the other way around. So it's important to take my feelings out of it, and this is a way to do that. All right. That is my somewhat brief introduction on the probability concept. Now, there are two ways to go in a discussion usually after this informal introduction. One way is to make this equally likely outcomes rather, more and more complicated, and make the experiment more and more complicated. And then we have different counting techniques to help us calculate that probability. But it's not that useful for me. I love that topic, but it's not going to give us as much benefit in the time that we have. The other approach is to stick to something more practical, keeping the probability calculation simple, but just getting an idea of uh, how these things are practically relevant. For that, we're going to move on to example, uh, exercise rather. That example, we've done that. We've done all that. It's in the book. Our probability definition here for equally likely outcomes. I'm going to do exercise 6.1. 6.1. Now, this is a big question. We might finish it today, we might not. I'm just going to go as far as I can go without rushing, getting everything out of this that I can. All right. Let's read it first. Not the whole thing, just the intro. Suppose a survey of 100 randomly selected students resulted in a sample of 60 male and 40 female students. Of the males, 2/3 graduated from a high school in the province, whereas the remainder had high school diplomas from out of the province. Of the females, 3/4 were from in-province high schools. First question, can I represent this information in a better way? Just in a more clear, structured way here. A table, maybe a table. Okay, so if I select a person, notice that that person has two traits, two qualities, two properties. They can be male or female, and they can come from in province or out of province. And any combination of those, right? So I'm going to make a table saying it doesn't matter which one is the row and which one is the column. Really doesn't matter. Let's go male and female. Make some lines here. It's big. And then in province and out of province. And I'm also going to keep track of the totals. Okay, so now what do I know and what can I sort of extract from this and put it into my table where it's easier to see what I have, easier to use for future questions. I have 100 students. Well, that's going to be my total over here. Then I have 60 male and 40 female. So 60 male and 40 female, of course, adding up to the 100. Working from the totals in based on how they gave it to me. Then, of the males, 2/3 graduated from a high school in the province. So of the 60 males, 2/3 of that, so 40, were in province. And then I know the other 20 were out of province because those are the only two options that a male could have for its other property. So I ideally want to I have to fill in all the numbers in this table. The remainder had high school diplomas from out of the province, obviously. Of the females, 3/4 were from in-province high schools. So of the females, there are 40 in province, 3/4, 30. And then the other 10 were out of province. Now I can also total up the in province as 70, out of province as 30, and check that they still give me 100, one way or the other. So there's my table. All the information is extracted very nicely. None of those messy words to hide information. Right, just check. Oops. Sure. Seem to have a tendency to speak too quietly and then it's not all recorded very clearly. Okay, anyway, try and fix that. Now let's see. So I've done number one. Technically, this was number one. They might ask me for a table. They might just start asking questions, and then I have to know that a table is one of my options. Okay. Second one, I just add here to remind myself to mention this. Is it possible to think of this as a probabilistic situation? So a situation where it's a probability question. It's a probability situation. If so, how? Absolutely, I can. Yes. I can make an experiment, or yeah, I can make or design an experiment. And the experiment is choose one of these people randomly. It has to be random so that each person is equally likely to be selected. Each person is equally likely to be selected because of the way I'm setting up my experiment. Each person equally likely to be selected. And that's very important for my way of calculating a probability. That I have to have everything equally likely. And then I simply count how many ways I can get what I want, divided by all possible ways. If I don't have equally likely outcomes, well, then this is a very different story, and we can't even touch that. But in this case, I certainly can mix up the people, select them randomly from a list, or however you want to do it. So I certainly can think of this as a probability. And then, for example, let me just check. Yeah, I can look at number 3. So if I randomly select a student, which we are doing, what's the probability that the student selected is an in-province high school graduate? Now, I will try and be precise here and say, let's say I can use any letter I want, or any symbol or anything. Let I represent the event that the selected student is, let's just say, in province. We all know what that means now. Then because every student is equally likely to be selected, I can say, well, the probability of getting this event's requirement is simply the number of ways, the number of ways I can get that requirement, whatever I call the event, divided by all possible ways. So now I go and count. How many students have the property of being an in-province student? 70. How many students are there in total? 100. Now I chose nice and easy numbers that you can then easily calculate this as 0.7, or you can say it as a percentage. Remember, we have two interpretations. Percentages are there to convey information in a more intuitive way, I suppose. We have a better feeling about percentages than we do little decimal fractions. So if I chose a person from the 100 people randomly walking around and I select them randomly, then 70% chance of getting an in-province student. Now you can interpret this and say, ooh, this is closer to 1 than it is to 0. So it's more likely than not getting an in-province student. If I were to select one person right now, um, I'm pretty confident I'll get an in-province student. It's fairly likely. But it's just a number to give me a sense of what I expect can happen or is most likely going to happen. I can also say if I select a person, I put them back, I mix them up, I select the person again. Every time I write down the in-province result of the person I select, and I keep doing it over and over and over and over. 70% of my results will be in-province, positive results. And the longer I go, the closer I'll get to that 70. Very important to interpret the probability value that you get, interpret it. And sometimes the first interpretation is nicer for me, sometimes the second, but I want to be comfortable with both. Okay, so far, so good, I hope. But I'm reading everything from the table. I can see this as a Venn diagram. I don't want to. I don't think it really adds anything in this case. But it's a similar idea that I have all the information. I have all the numbers in their separate positions. Depending on the question, I then just extract that information from my table depending on what they're looking for. Let's see the next one. Trying not to hurry. Take my time. Getting used to this probability concept, but to some degree, the probability concept isn't completely new for most. Let us see. What is the probability that a student graduated from an in-province school or is female? Now I already have I as in-province, my event. So let's define, in addition to the I, let's also define F to represent the event that the selected person, students or person, is female. Then, what are they looking for? They are looking for the student being in province or female, or it could be both. I have to get to the point where I am comfortable with understanding and recognizing that that is a union. One or the other or both. They don't always say the both, but of course, looking at my table, both can be possible. It doesn't matter. It's just a restriction that I have to count how many ways can I get that restriction and divide it by all possible ways. So I'm looking for in province or female or both. Let's see. So in province, so I'm going to make it pink. In province, those are in province, those are in province. Those are female. And this 30 happens to be both. So all of those together will satisfy the restriction in one way or another. Some just in province, some just female, and some both. So we are doing Venn diagram stuff. It's just maybe in the background. The table is, in my opinion, for this first step, more clear. So I have 80. 80 students satisfy that restriction, or I can satisfy that restriction in 80 different ways of the 100 that I could select, of course. Write that as a decimal, write that as a percentage. It either way gives you an indication of how likely that is. So now I can compare because I might not have a good intuition for these things. If someone asked me, what's the probability or how likely is it of getting an improv student? I'd say, looking at the table, yeah, I guess it's fairly likely. Maybe I have a good feeling that the numbers aren't complicated, the number of options aren't complicated. Yeah, sure. I see there are 70 there out of 100. Yeah, fairly complicated, whether I know how to calculate a probability or not. And then someone asks me, well, what is the probability? Or maybe I don't look at the table. I don't look. Yeah. What is the probability of being an improv student or female? Like, yes, it feels more likely because I now have another female restriction that could also give me what I'm looking for. Feels more likely, doesn't it? How much more likely? A lot? A little? Is it close? I don't know. By calculating a specific or by getting a specific number, I can say it is 10% more. It is this close. It's more likely, not by a lot, or in other cases, by a lot. I have numbers and they're easier to compare than words and vague, unintuitive concepts when these can maybe get more complicated. You can very easily look at this and say, yeah, of course it's more likely. But it's hard to know in some cases, even if you're correct, how much more likely. Is it close? Is it pretty much the same? Maybe it is the same. Maybe I don't know. Maybe it's counterintuitive. This number allows me to specifically say that is how likely it is. This is how they compare. Makes it much more precise, I suppose. Number five. Five. What is the probability that a student both graduated from in province and is female? So I already have those two. So now we need to find, remember the and word was associated with intersection. So I'm looking for the intersection of the two. Now I don't think of this as Venn diagrams. I don't visualize a Venn diagram. I think about what this combination is requiring me, what kind of people am I now required to look for? It's in province and female together, both. I want to get used to reading these sets, events, and uh, ways of combining them and understanding the restriction that they place and not thinking about Venn diagrams. I need to move past that. They are putting a restriction on what I'm looking for. Now I can go to my table and find out, well, how many ways can I get that? In province and female. It's only this 30. Has to be in province and has to be female. The row and the column overlap in the 30. So I could then say I can get that with 30 people out of 100, 0.3, 30% interpreted in either way or both. I can see, well, it's beginning to not be that likely. It is closer to 0 than it is to 1. I'm going to get it sometimes. It's not impossible, but most of the time I won't. And if I keep doing it, only around a third of the selections will have in province and female. I'm going to insert a little 5b here, just the probability of getting a female. Let me just check if that's what I'm looking for. Then it's simply the number of ways of getting female divided by all possible ways, right? I've had the table, and I just have to identify, whether I write it in sets or not, what numbers I am looking for. What am I interested in? In this case, just the female, but any in province or out of province, so 40. So 40 out of 100 will be female. And then, perhaps intuitively, perhaps not, we can say, well, yeah, this should be at least as big as the number 5 one, because number 5 required female, and on top of that, at the same time, in province as well. So that could restrict my options further, resulting in fewer possibilities and a lower probability. Okay. 5 minutes to not do this number 6. You can think about number 6 if you want, but to set the stage. Let's read it and try and understand how this is different from all the other questions. What's the probability that a student graduated from an in-province high school, given that the student is female? Actually, no, let me do it. Yeah, it's okay. This is different. I'm looking for the probability the student was in province. But I know, I'm given information, the student is female. Which means I'm not looking at all possible people. Someone tells me they've selected a person. They look at the person and their information, and it's a female. Then they come to me. Look, I've selected a female. This is a fact because I've secretly already done it. How likely do you think it is that the person graduated from in the province? So now this changes the question, in that I know it's a fact the selection was one of the female, not the males. And on top of that, using that extra information, I want to ask, how likely is it to be in province? So I've now narrowed my view. I've restricted my view to only look at females because I know it's a female. There is no chance it's being a male. So the sample space is reduced to only look at females. And using that extra information, knowing it's a female, how likely is it now to be in province? 30 out of 40. Because only 40 are possible. If you tell me a female was selected, only 40 people are possible. Given that information, how likely is it to be in province? This is a completely different situation because I'm not looking at the whole table anymore. As soon as I have extra information, then it throws away some of this. In this case, it throws away the males, because if you tell me, you secretly go and select a person. You know they're female and you tell me, I selected a female. How likely is it to be in province? I can use that information to say, well, I don't even have to look at the 60 because they're not possible. You told me it's a female. So out of the 40 that are now possible, only 30 will be in province. Now we're not going to write this in words right now. I'm just going to write it. Well, I'm not going to write it symbolically. I'm going to write it in words. Sorry. The probability of uh, selecting female given, the key word is that given. No, no, no. Other way around, right? Female is given. There. The probability of selecting in province given female is, say, 30 out of 40. 30 out of 40. I can calculate this or whatever, right? Now, it takes a while perhaps to wrap your head around this key word and how it changes the way I look at it completely. We'll sort of revisit this tomorrow. Just let it sit right now. Don't worry about this right now. I want to sort of plant the seed and then we'll solidify it tomorrow. Once it sort of gets processed, you sleep on it and so on. Think about the others. Get used to the probability concept. How do I interpret it? How do I calculate it? Still a lot of things to get used to. I want to plant the seed that there is another kind of probability to ask. A probability where more information is known about the result. And that reduces my options. It reduces this bottom one. It's not the sample space in the original sense anymore. It's a reduced sample space because the because the extra given information throws some options away that I know are impossible. Out of what's left to be possible, what are my chances? Well, it's a different kind of probability. So think about it if you want to, if the rest is already easy, or focus on the rest, and we will build on this in the next few sessions. Any questions before we pause here to continue later? Now, let me go to the problems because people are obsessed with problems. And ease your mind by saying, don't do any of them. Don't do any of them. Simple. See, don't look at any problems. You have enough to do. And if you're perfectly caught up, today was crystal clear, then relax. Take it easy. Do something else. But we need a few sessions to really get on top of, especially this last one, because that's where the practical situations are mainly. This given information comes up a lot. And I need to figure out how to deal with that first and get used to the difference that this question has. All right. Doesn't sound like there are any questions. Then we will pick this up tomorrow. Until